So what I was saying was, I know you're anxious about all these things that are going on. We all are. But instead of exerting yourself and doing worrying, which is not going to help you, you're not going to change all these things that are going on. Just take it one day at a time. We'll figure out whether we're even coming back to school when everything is said and done, because I'm sure all of you are very aware of the fact that in the news they're talking about closing down all these schools, and who knows if that's going to affect us. But, the main thing is that we're trying not to convene in groups of 200 or more, because you up your chances of being exposed to all these germs. So they're trying to cut down on large-scale gatherings, which is exactly what you're doing when you go to school. So I don't know what's going to happen. All I know is that I got an email saying that as instructors, we need to be ready to spring into teaching online. Well, I already do that. You guys know that I bother you a lot with my announcements, and of course I've already been regularly posting videos. So if we just have to continue that, then that's what we do. What we're going to do about testing, I don't know. But we'll figure it out. We'll figure out what to do if and when that happens. Because evidently what happened last night was that many of the state universities closed down, and they want everyone to go home to their homes for the next couple of weeks, but I don't see how that's going to help, because if anything, this is something that grows exponentially. It doesn't just double and triple, it grows exponentially, and it'll be like that for a while, but I'm sure right now they have the best and the brightest working on, like a cure for that thing, and they can maybe find something and that'll make it. But what kind of minimizes this just spreading globally is doing things like not meeting in huge groups. That's why they're shutting everything down, canceling events, probably a lot of the events. So for all of you that were packing up your bag and whatever else it is you take to go to that Ultra Festival, canceled. It's all canceled. Everything's been canceled. So, you can put your bottles of water away and whatever else it is that you take, and stay at home. So what could I post for you for a present? Well, all the stores are out of toilet paper, and what else are they out of? Hand sanitizer. Oh, I got a homemade recipe for that. Okay, I got a homemade recipe for how you can make your own hand sanitizer. I'll post it on the announcement board. All you need is alcohol and a couple of other minimal things.
I work at Winn-Dixie, and we're out of hand sanitizer, we're out of the Lysol, cleaning wise. I was just trying to find multi-purpose cleaner, just for my own, cleaning sake. I mostly get, 407, because it works really well. And I had to, be super careful, because it only, disinfectant had essential oils in it. I'm not putting essential oils in my cats.
Yeah.
If they look it, they get sick. And they're little greedy bastards that love to.
Oh, well, that sounds involved. Well, I could tell you, I go to a doctor that's like an Eastern medicine type. Everything's natural. So she gave me a recipe for natural hand sanitizer. I'll post it on the announcement board, and you guys can brew up a batch at home so that you can wipe your hands. So it's good stuff. It's really good stuff, natural. No, last night they said 10 times. What I heard last night was the Surgeon General. He was on TV saying it was 10 times deadlier than a regular cold. That's what I heard. So I don't know. The flu. 10 times deadlier than the flu.
Well, the problem is they get statistics of who's been tested and all that, and there's a lot of mild cases that people just don't go to the doctor and get tested.
Yeah.
And I think there's a certain criteria to be tested. So,
If you're old or young.
Yeah, a lot of people are not even getting tested.
I better get
so
home.
they
I better
don't
get
know
home.
The actual numbers are just going based on what they've seen so far.
Dang, I don't even know if I should be here now. I better hurry up and skedaddle out of here.
Testing alone, it's $1,000 just to get tested. Just to get one test is $1,000-something.
What?
Yeah.
I don't have $1,000.
They have tests for it, but a lot of the tests are staged, China, Korea, Italy.
So,
They're healthy people.
I'm scared. I don't know if I can teach.
what you were just saying, like, if, say, I would get it, and I'll have mild symptoms that don't bother me, and somebody else gets it, and they're down for 2 weeks.
Yeah, right.
It's just based on the person, based on your system, your age, a lot of factors.
Well, I'm going to be in touch with you over the break. If I need to tell you anything, or if you need to get a hold of me, you know how to reach me, and you know that I answer my emails right away because they come in on my phone. So you know that a lot of times, even if you're contacting me at midnight, boom, I'm in there because I'm on my phone and I'm on my computer at that time, and I'll be glued to a computer the entire spring break because I have to write the entire time. I probably won't get up, and probably I just won't even shower or anything. I'll just, I'll just keep writing. So anyway, no, I can't. I have deadlines. I have people that are on my back saying, Zeiss, where's chapter 2? Zeiss, where's chapter 3? Because I told you I'm going to school right now. And so I'm trying to please my committee chair because I want her to be happy. And I'm going to make sure that I don't let her down.
Get like a hot spot, bring your laptop to the beach.
Get some Hot Pockets? What'd you say?
Hot spot.
Oh, hot sauce.
Yes, get hot sauce, put it on your phone.
I do that. Hot sauce. Yeah, I will. I don't know. I'll try to fit some fun in. We'll see what happens. Like, I should have been writing last night, and instead I went to a concert, and I was like, and I was scared at the concert though, because there were so many people, and they were all older than me, if that's even possible. And I was like, oh God, they're all sick. So I don't know how much I'm gonna go out. We'll see what happens.
I'm bringing my laptop with me, this. Like, I have a marketing plan to write that's already, 10 pages long. I'm not going through it. They're like, no, you can't bring it. I'm like, bring it in. You're not stopping me. There's going to be times that, early in the morning, I'm going to wake up randomly. I have to pull up my laptop.
Yeah. Yeah. Well, like I said, I'll be in touch with you, and if anything happens, you're going to hear through the main website, but you'll probably hear from me also, and I'll let you know what's happening, but everything should be fine. Save your energy for washing your hands and staying away from big crowds, less worrying, because what can you do about it anyway? Okay, so here we go. We're going to start with number 4. I am right on schedule here. We are scheduled to finish with section 3.4, and that's exactly where we are. So we're not behind or anything. We're looking pretty good going into the last few weeks of this class when you come back. Okay, so if you weren't here, you were at home recovering from rape party or whatever it is you do, then you didn't see this, so I'll start all over again. Okay, so in section 3.3, we were doing synthetic division, but do you remember that they always gave us a number to put in the box? Now you have nothing. So how do you get the darn thing started? Because the only way you can start to begin to find the zeros, the solutions, or x-intercepts, they go by 3 different names, is if you do synthetic, but you need a number to throw in the box. So here's 2 ways that they gave you that number in the last section. They would either they would say divide by x minus 3. Divide by x minus 3. And then remember, we would break those apart by switching the sign, and we would deliver it to the little synthetic box. Or instead of attaching a number to an x, they would say the first 0 is the number 2. And in that case, you would put the 2 right in the little synthetic box as is without switching the sign. So a big point that I tried to make in the last section was, when do you switch the sign before you put the number in the box, and when do you leave it alone? That was a big point that I tried to make. However, now you come here, nobody's telling you what to divide by, and nobody is telling you, hey, here's the first answer. Go dump this number in the box and continue with the synthetic. So now you're going to generate your own possibilities. For numbers that you should put in the little synthetic box, you're going to generate your own possibilities. So this is called the list of possible Now they're all going to be fractional in form, and another name for fractional is rational. The list of possible rational zeros. Remember, the word zeros also means solutions. Can also be called the x-intercepts if you're graphing, if you're in a graphing frame of mind. But right now we are very heavily using the word zeros. Okay, so I have nothing to start off my synthetic process, and whenever you're in the third degree, fourth degree, because if it was just second degree, I would just tell you, hey, go factor and find the zeros or the solutions. That would be your way of handling it. But once you get to third degree and fourth degree, you have to start this problem off in a different manner, and that manner is synthetic division. So if you're going to do synthetic division, you need something to put in that little box. So we're going to generate this list of possible rational zeros. They always look like this. You're considering both the positive and the negative version of these fractional numbers. The p's, they come from the factors of the constant. And we're even going to highlight this. These, the denominators come from the factors of the leading coefficient. So all of that is from right here. Okay, that's all about that guy right there. The denominators will be all the factors of the leading coefficient. Well, I love it when it's a number 1 because the only way that factors is 1 times 1. So what are the factors of the leading coefficient? Just 1. Then the factors of the constant, that makes up the top of these fractions. That's this guy down here. What are all the factors of that number that's in the back? Well, let's see. This breaks down only into 5 times 11. You're not worried about the negative. You just need to, what are all the different ways you could break down 55? You could either go 5 times 11 or you could go 1 times 55. Okay, so the number 5 is a factor, the number 11 is a factor, the number 1 is a factor, and the number 55 is a factor. Factors of this number, just 1, because the same number repeats. Okay, so here we go. Let's make this list. Everything in our list will be a fraction. The top numbers will only come from the factors of the back number. The bottom, the denominator, only comes from the factors of the leading coefficient. So I'm going to write it like this, like a set. I'm going to put the fact that I should be considering both the positive and the negative versions of these fractions that I'm about to create. Okay, so remember, for the tops of your fraction, you're using the numbers down there. For the bottoms of the fraction, you're using the numbers from up in the front. Okay, so my bottoms are always going to be 1. I'm going to go in order here. I'm going to go from smallest to biggest. Smallest number here is a 1. So it's 1 over factors of the front. Next biggest number is a 5. Probably cross them out as I use them. Using any of these as the top and the factors from down here as the bottoms. And you can just, if you know that the denominator is a 1, you could just call it 1, 5, 11, 55. Okay, so there's my list. If you want to give it, without the 1s, that's up to you. Okay, so this is part A. In part A of that problem, it said, list all the rational zeros. List all the rational zeros that are possible according to the rational zero theorem. I just did that. Now when you go to find the ones in this list that actually are the zeros, those are called the actual zeros. Let me see what kind of wording they used with you. They used the word actual. So use synthetic division to identify at least one actual zero. Now, here's what I want to get you to understand. What?
You left the 5 off.
Sorry, thank you. Okay, so what I want to get in you is the fact that when you go to find the actual zeros, you're finding the numbers that actually work in the equation. And every time I find one, I'm going to knock this thing down a degree. Look what degree this starts off as. Because you should write some notes with regard to this. Do you see that the original problem's third degree? That means it's 3 solutions. In other words, 3 zeros. They are called zeros, or you could call them solutions. I'm going to be looking for 3 answers total. However, I might not be able to factor this by grouping. In fact, this doesn't factor by grouping, because some of the students the other day were saying to me, hey, it might have been you. What? I don't know if it was you or not, but somebody up here was saying, hey, I could have started that problem and did the whole thing by factor by grouping. Can I do it that way? You can if I don't tell you in the test, hey, you must start it this way. Now, this problem, you don't have a choice. That thing doesn't factor. This does not factor by grouping. The numbers don't work out. So you have no choice but to have to start the problem like this. So every time I find a 0, I'm going to knock this down to a degree. My whole goal is to get to second degree, and then I'm going to take over with factoring. I'll forget the synthetic, and then I'll take over with factoring. Now, the annoying part of this is that you don't know which of these values are going to work. So my suggestion to you would just be start with the smallest one. Don't forget you could use the positive or the negative version as you try to use synthetic division to find your first 0. Okay, so a review of the last section. How to do synthetic division. Take the numbers and stretch them out going across. 1, 9, negative 47, negative 55. I'm looking for this thing to 0 out, and then I'll know that the this number 1 right here is an answer or a solution. If it doesn't 0 out, I have to do this all over again, but try a different number here. Okay, so drop down the 1. 1 times 1 is 1. Add these, you get 10. 1 times 10 is 10. Add these, you get negative 37. You can already see that that's not going to work, right? When you add these, you don't get 0, you get negative 92. So that doesn't work. Let's go again. This time I'm going to use the same number, but again, 1, 9, negative 47, and negative 55. Leave some room. Drop down the first number and start multiplying and adding. So it's negative 1 times 1, negative 1. Add these up, get 8. Negative 1 times 8, negative 8. Add these and you get, let's see, that would be negative 55. There's one right there. I could see that this is going to 0 out because when you get these, you get negative. When you add these, you get negative 55. That times that is positive 55. So by the time you get to the last column, you're 0ing out. You 0ing out like that means that this is a solution, also known as a 0. Because the fact that this 0'd out, that indicated that I just found one of the answers. Okay, let's start the solution set right here. This is one of my solutions, or zeros, and then I got to find 2 more. Again, I'll keep reminding you, whatever the degree of the problem is, that's how many total answers you should find. I found 1, I need to find 2 more. Okay, but what are you going to do to find these answers? Are you going to go back up to this list and try 5, then negative 5, 11, then negative 11? You could just factor, right? Once you get to second degree, the easiest and quickest way to finish the problem is to get in there and factor. Okay, so how do you factor at this point? I was telling you that every time you find a 0, every time you find a solution, and you'll know because it's 0'd out, you have just done what's called decompressing. You took it from whatever degree it was at to 1 degree lower. So you see how this thing started at 3rd degree? We're now at 2nd degree. Let's put the letters back on these numbers. This would be the 2nd degree term. This would be the 1st degree term. This would be the no degree term. If there's a blank spot in between 2 terms, that means it's positive. So we're going to be factoring this. Just set it equal to 0 as though it's an equation and factor it. And if it doesn't factor, then we're going to find the answers by quadratic formula. But this is the quickest way to find these answers. So let's see, what would it be? 11 and 5? Yeah, 11 times 5 is 55. Remember, when you're factoring by guess and check, and you got 1 out here, I think you can pretty much, you guys are good enough that you can do that in your head. But if you can't, here's for the people that cannot hold all this in their head. You're just looking for two numbers that multiply to give you 55. That means you got to be pretty good at your times tables. But you should also be able to add those numbers to get the number in the middle. So let's see. Will 5 and 11 work? Because if I can't find the numbers, that means this thing doesn't factor. No, 5 and 11 doesn't work because 5 times 11 is this. But when you add 5 and 11, even if you were to, because you can ask yourself, can I either add or subtract them to get that number? But nothing's going to work. If you subtract these, you get a 6. So this doesn't work. What was our other options? 1 times 55? That's definitely not going to work. So do you see that this thing won't factor? Because the numbers won't work. 1 times 55 is 55, but 1 plus 55 is definitely not 8. When this will not factor, do what you always do when something won't factor and you're trying to find the two answers from second degree. You take over with quadratic formula. So here we go, trying to find the remaining two answers for this. Okay, whenever factoring won't work, let a quadratic formula take over. That formula is this: opposite of b plus or minus b squared minus 4 times a times c, all over 2 times a. Okay, so it's opposite of b plus or minus. Let me get myself ready here. All right, so the b value is this. This is the c value. This is the a value. Just go plug those things right in here. So b gets plugged in here as well as here. My a value gets plugged in here as well as here. And then all the way on the back end goes the negative 55. Okay, I'm going to do a little bit of work right here so I don't have to write it over again. I got a 64 going on at the front. And then I got negative times another negative down the way. That's going to be positive. 4 times 55 is going to be 220. So by the time I add the 220 that I got off of the 4 times 55 and I add the 64, that's 284 altogether underneath that radical. So now this whittles down to negative 8 plus or minus inside the radical 284. And a 2 in the denominator. Okay, now I believe that there is no square root for the entire number 284. But there is a partial square root for that. So if something ends in 4 like this, it's divisible by 4. 4 goes into this. Let me see. We're going to the back number 1 time and into this part 7 times. So 71. This is 4 times 71. That's the 284 that you see underneath there. I will be able to take the square root of 4. That'll come right up out here. And the 71 is going to have to stay inside. So that's called taking a partial square root. So I'll put the final answer over here. Almost the final answer. So it's the negative 8 that's out front, plus or minus. This square root of 4, I am floating it out and taking the square root as I do so, leaving the 71 inside and the 2 down at the bottom. Still not done. One little step left. See these numbers that are all on the outside of the radical? They're all considered part of the coefficient. If they are all divisible by some number, you are to reduce it. So negative 8 divided by 2, negative 4. With the plus or minus right after it. The 2 that you see in front of the square root of 71, that becomes a 1. The denominator becomes a 1. That's your final answer. So when you go to list your answers, I know I started my set there, but I really don't have enough room. So when you go to give your answers in my math lab, you would say the -1 was one of the answers. This was the second answer. And this was the third answer. Once in a while, like when you're trying to feed your answers in, I notice that sometimes they will offer you, like down at the bottom of the screen, the plus or minus symbol. And sometimes they make you feed the answers in like this separately. So this is what it does. Separate? Yeah, and then depending on who's programming that particular problem, sometimes it does have the plus or minus, but rarely do I see that. All right, so let's see. I think that's it for number 4. Let's go to number 5. Oh, no, wait, there was, I did it all. I did everything. So this was part A right here where I was looking for one of the answers through synthetic. Then they told me to factor it. I could not factor it. And then I had to take over with quadratic formula. That was part C where you list all the answers. Okay, let's go to number 5. Now, before I do number 5, because 5, I'm going to have to push up your level of intelligence. When we go to do number 5, it's a little bit harder. So what have I left out here? Did I do number 2? Or did you guys just have number 3 there? Do you guys have any work for number 2? Okay, so before I take you to the hardest one, which is going to be the hardest 2 or 5 or 6, you know that everything I've done has been third degree? And I don't feel like I've given you enough examples yet, so I'm going to do number 2 as well. The reason I skipped over number 1 is because in number 1, all they're asking you to do is to make that list of fractions. And I'm doing that in all my examples, so I'm practicing that. But do let me go back and do number 2. And I'm going to do it all for this problem. I am going to make the list and find the things that work. Okay, so let's copy the problem. All right, here we go. So we're doing the list, the positive or negative P over Q's. Here's my list. I'll just throw that plus or minus right out in front so I don't have to put that in front of every single number. Let's factor these things down. Let's see, so that factors like that, or I could factor it like that, or I could factor it like this. Remember, your P's are all about this last, the constant, and all the ways that you can break it down. Thank God we only have a 1 right here. That makes it a lot easier than it might have been. The only way you can break this down is 1 times 1, and this is all about the Q's. The Q's that make up the bottom. So here we go, making up the fractions. I'm going to start with the smallest thing in this list and then go to the largest. So it's 1 over 1, 2 over 1, 4 over 1, 5 over 1. I mean, I could write them all over 1 if you want to, but I'm just jumping into reducing them. 10 over 1, 20 over 1. Any questions about where that list came from? Again, I'm making my own possibilities here. I'm generating my own possibilities so that I can start the synthetic process. So in that little box, I'm going to start with the smallest one. That's what I like to start with. I don't know which of these are going to work. I mean, if you were really unlucky, you would try every single number, and it wouldn't be until you got to the last one that it worked. So that wouldn't be fun. But usually one of the smaller ones works. So I'm going to try the number 1. I'm going to stretch out these numbers, third degree, second degree coefficient, first degree coefficient, and the constant. Make sure you have 1 for each and every power. Put the line underneath it, and I'll keep doing this until I find one that zeroes out. Okay, so bring this down. So 1 times 1 is 1. Add these up. You get negative 4. 1 times negative 4 is negative 4. 1 times negative 8 is okay, that's not going to work. Let's try the negative 1. Same numbers though. 1, negative 5, negative 4, and a 20. Put the line underneath it. Drop down the first number. Start multiplying. This times this is negative 1. Add these up, you get negative 6. That times that is 6. Add these up, you get 2. This times this is negative 2. Also does not work. Let's get into the next number, which is the number 2. Hoping this doesn't go on for too long. So the numbers again were 1, negative 5, negative 4, and a 20. Drop that down, that's 2. Add those up, you get negative 3. That times that is negative 6. Add these up. I think this one's going to work. And then 2 times negative 10, there you go, right there. Okay, as soon as you see yourself zeroing out, you have just found one of the answers. Okay, so 2 is one of my answers. And also, in finding one of the answers, you've gone from 3rd degree down a notch. So now we're at 2nd degree, meaning these numbers right here, first term is your 2nd degree term, this is your 1st degree term, this is your constant. Make an equation out of that and see if you can factor it, because quadratic formula is a lot of work. I don't want to go there unless I have to. I had to in the last problem. Now that's going to factor, because what numbers can you multiply together to get 10 but add to get negative 3? 5. Good. See, that one's easy. There's actually numbers. So I'll make that the negative 5. I'll make this the positive 2. So 2 times negative 5 is negative 10, but when you add those two numbers, you get negative 3. So that works. Make little equations out of these, or just jump to the answers. They are the opposite of what you're seeing here. So one of the answers is negative 2, opposite of that. One of the answers is 5, opposite of that one. Okay, so now I got all 3 answers. All right, so the first one I found like this through my synthetic work. The second one I found and then the second and the third one I found through factoring. All right? All right, though I think you're pretty good with 3rd degree. Let's bump it up a notch. We're going to go to 4th degree now, and then we're going to finish this discussion. We'll do it going backwards. You know how I'm asking you for the zeros? For the last problem, I'll give you the zeros, and you work backwards to develop the equation that they came from. So one more of these, but a little bit harder. Okay, we're doing number 5. Now, you know, sometimes they call it f of x, but they don't have to put the f of x there. They could just give you the polynomial, set it equal to 0, which is what they have done in this particular problem. Doesn't matter which way they present it. You're still starting it off the same way. Okay, so this time they give you the polynomial without the f of x in the front. All right, so let's see. We're going to make our own list because we have nothing to start the synthetic off. But do you see that this one starts at 4th degree? So even if I do find a 0, I'm only going to be at 3rd degree. I'm going to have to bring it down again. So you know how passing, doing one cycle of synthetic and looking for, you're going to bring it down to 4th degree, then you're going to keep doing synthetic, bring it down to 3rd degree, and when you finally get to 2nd degree, then you can go and factor it. Okay, we're going to have to take 2 passes through this. We're going to have to find 2 zeros the synthetic way. Let's make the list first. It'll be easy. So plus or minus, put that in front of this. Let's make the list. The list is not that big because look, the only way you can break this down is either 4 times 1 or 2 times 2. So really there's only 3 different numbers here, a 1, a 2, and a 4. And this is really nice because that only breaks down as 1 times 1. Remember, these are your P's, the top numbers. These are your Q's. So if I'm going to start making these fractions, always letting these be the tops and these be the bottoms, it would be 1 over 1, 2 over 1. I already used the 2, so cross that one out also. No need to do it twice. 4 over 1. So if I was to say to you, how many possibilities do you have there? How many things do you see there? It looks like there's 3, but there's really 6, aren't there? Because aren't you supposed to be considering both the positive and the negative versions of those numbers? So you really have 6 different options for what you could put in that little box. Okay, so these are called the possible, rational, because they all started off as fractions. It's just that instead of going 1 over 1, I said 1 instead of going 2 over 1. So these are called the possible, rational zeros. Now I'm going to find the actual zeros. Okay, so in a little box, first I'm going to try the 1. I'm going to stretch out these numbers, coefficients, 1, 6, negative 3, negative 24, and negative 4. Put a line there, drop the first 1. We're looking for the first number to zero out. So 1 times 1 is 1, put it there, add these up, you get a 7. 1 times 7 is 7, put it there, add these up, you get a 4. 1 times 4 is 4, put it here. This is not going to work because it didn't zero out, so that did not work. Let's try negative 1. Okay, negative 1. Stretch out the numbers again horizontally. It's 1, 6, negative 3, negative 24, negative 4. Leave room underneath these numbers. Drop the first number. And keep multiplying and adding till you get to the end. So this times this is negative 1. Add these up, you get a 5. That times that is negative 5. Add these up, you get a negative 8. That times that is 8. Add these up, and you get negative 16. That time, nope. No good. Okay, hopefully you have better luck with the 2's. So here's a 2. Now, you know, like some of my students today were saying, at this point, haven't I tried 2 of the 6 possible values that I had? So I got 4 more that I can try. So some students are saying to me, well, don't the other 4 have to work? Do you remember in the problem, another problem I did today, that some of the answers came out to be radicals? The only things that are in this actual list are things that are fractional, not radicals. So no, it's not, that doesn't necessarily mean that because I used 2 of these and they didn't work, that the other 4 answers work. Some of the answers in here will work. Okay, so here we go. Let's try 2. So stretch out the numbers again. 1, 6, negative 3, negative 24, negative 4. Put the line underneath it. Hopefully this will be our lucky one. 1 times 2 is 2. Add these up, get an 8. 2 times 8, 16. Add these up, and you get 13. 2 times 13, 26. Add these up. Here's one right here. Get a 2. 2 times 2, there you go. We just zeroed out. So because we zeroed out, that means we just found one of the answers. Okay, now let's see if you're with me here. What degree am I down to at this point? I'm at 3rd degree right now. I was at 4th degree. And by the time you find a 0, that brings you down a notch. So you're at 3rd degree, not ready to factor yet. I want you to get us down to 2nd degree. So keep going. But you know what I want you to do? I don't want you to go back to the original because then you'll be right back up to 4th degree. Why don't we work off of what we have right now? this decompressed string of numbers where we're at third degree, go right off of that, because then you'll go from third degree to second degree. If you keep reusing the original string of numbers, you'll keep starting back at fourth degree, and all you'll achieve is getting back to third degree each time. So if you want to work off of this third degree string that you have right now, what's the next number that we're going to try? -2, but we're going to try it right here. We're going to make this thing go down further. We're just going to build right off of the line that we have. So we had brought ourselves down to third degree by finding a 0. These are the numbers that resulted. The next thing in the list is -2. I'm going to see if that will zero out. By the way, you don't need to mess with that last column anymore. You're just trying it on these numbers right here and seeing if you zero out. Yes? How do you know it works? I haven't tried it yet. I know, but no one else. Yeah, because you definitely don't want to try it in the original, because if you try it in the original, where are you at? Third degree? And the whole point is to get yourself in a scenario where you can factor. You know what allows you to factor? Getting to second degree. So if you tried the -2 on the original, yes, you found out that it worked, but you didn't get yourself down to second degree. You're only at third degree. See, I'm killing two birds with one stone. I'm finding out what works, plus I'm getting myself in a factoring position, which is going to happen in about 2 seconds. Okay, so I had this string of numbers. Drop down the first one, go to that times -2, add these up, you get a 6. That times that is -12, add these up, you get a 1. That times that is negative, and there you go, zeroing out again. Every time you zero it out, you bring yourself down by a degree. So I was at third degree when I was right here. Now I'm at second degree. That's called decompressing. Every single time you zero out, you decompress it. So if I'm at second degree, what that means is that this first term is second degree. That's first degree. That's the constant. These blank spots get filled in with plus signs. So I'm trying to ask myself, how do I solve this second degree equation that I have left? What do you think? Do you think that's going to factor? No, because, I mean, look at the number that you have on the end. Because knowing whether it's going to factor is all about this guy. I mean, how do you break down the number 1? 1 times 1? But when you go 1 and 1, you surely don't get a 6 out of that. You should be able to multiply two numbers together that multiply to give you that, but they should also add to give you that, and that's impossible. So when it is impossible to factor, jump into quadratic formula to finish the problem. Okay, this won't factor. I already did one problem like that because I knew you were going to run into plenty of them when you do my math lab. So when it won't factor, do what you always do when it won't factor. You use quadratic formula to finish the problem. So use the quadratic formula to solve the second degree equation. That's what quadratic formula is for. It's for the things that won't factor. Okay, so here we go. The answers to x are opposite of b, plus or minus b squared minus 4 times a times c, all over 2 times a. That's why I keep telling you to factor, because who wants to get into all of this? That's a lot of steps. So that's why you should always factor if possible, but we couldn't do it. All right, so my a value is 1. My b value is right there. My c value is also 1. Okay, plopping the b value into these first two positions. The a value goes here and here. And the c value goes on, what was the b value? That was 6. My a value was 1, and then my c value goes down here. That was also 1. Okay, whittling this down a little bit. I'm going to do a little bit of my work right here. This will be 36, and then minus 4 down at the back end. So 36 minus 4, that's 32. So it's -6 plus or minus 32 underneath the radical instead of all that. Yeah. Let's break this 32 down. So we're going to go 16. I mean, I know some of you are going to want to break that down as 4 times 8, but then you'd have to turn around and break the 8 down again. So try to think of the biggest number that goes into that there's actually a square root for. So we're going to take the square root of that, and it'll come out as a 4. So it's -6 plus or minus. 4 floats out right there. That 16's been dealt with. It came out as a 4, and the only thing left underneath the radical is a 2. In the end, if you reduce, you're only reducing these numbers, never the number inside the radical. So 2 goes into that, and that. Most simplified answer here, -3 plus or minus 2 square roots of 2. Okay, so all of your answers for this problem are the following. I found 2 of them by synthetic and the other 2 by quadratic formula. So if they ask you what the answers are, here they are. One of them's 2. One of them's -2. One of them's -3 plus 2 square roots of 2. The other one's -3 minus 2 square roots of 2. Those are the 4 answers. Whoa. Just like you were supposed to have. You can put them all in a little set symbol if you want. -2, +2. I found those by synthetic, and I found these by quadratic formula. Again, essence of the whole section, bring it down to second degree. You will use synthetic to do that, to bring it from whatever I give you. I could give you 5th degree if I wanted to. Maybe I will for extra credit. And you keep bringing it down through synthetic by using numbers that are inside the set. You keep trying them one at a time. Every time you get it to 0 out, you have brought it down another degree until you get it to second degree, and then you leave the synthetic alone and finish it with factoring or quadratic formula. Okay, last problem. And then you're free to go on spring break and do what you do. But stay indoors while you're doing it. That's not fun. Okay. But it kind of was. Okay. All right, so we're going to go back the other way. Going backwards now. Okay, so in all these other problems, I asked you to find the zeros. I'm telling you what they are. I have to give you an extra little theorem here. By the way, when it says n equal to 3, that means you should end up with a 3rd degree equation. I want you to produce the 3rd degree equation that has these zeros. So there is this theorem that talks about the types of solutions that you can have. I'm telling you, one of the solutions is 3, and the other one's an imaginary number called 4i. So it just so happens that when you're talking solutions, that if any kind of imaginary solution that you have, they come in pairs. See, these imaginary guys don't hang around unless they have their cousins with them. So whenever you do have an imaginary solution, the conjugate cousin to this is also a solution. And that's actually a theorem in mathematics, that imaginary solutions come in conjugate pairs. What does conjugate mean? Switch the sign. So if positive 4i is a solution, negative 4i is also a solution. And they're not going to give it to you. They're going to expect you to know that theorem. So put in here, imaginary solutions come in conjugate pairs. Not real numbers. That's a real number. That number 3 that you see out there, that's called a real number. This is called an imaginary number. Not too hard to see because one's got an I and the other one doesn't. So imaginary solutions such as these come in conjugate pairs always, even though they might not mention who the other solution is. Come in conjugate pairs. So if somebody says 4i is a solution, then negative 4i is also a solution. That's what it means to have for imaginary solutions to come in conjugate pairs. All right, so I'm supposed to be coming up with the function that these solutions came from. So here we go. We're going to call it f of x. Okay, now let's see if you can piece this together. The solutions that you give me at the end, when they're in factored form, they have the opposite sign. Do you remember how, like the last part of these problems, how I factored? And if I had x minus 5, wasn't positive 5 the answer? If I had x plus 2 in the factor, wasn't negative 2 the answer? So what they look like when they're in parentheses are the opposite of what they look like as a solution. So to get that to happen in your problem, just make sure that when you're going to start off as though it's in factored form. You know why I have 3 of these? Because it's supposed to be third degree. So I should have 3 solutions. I want you to put an x at the front of each one. This is going to make the signs switch so that what they look like in the end will be the opposite of what they look like here. Put a minus after each one. That's what the job of that minus is. Dump in the 3 solutions that you've been told exist. One of them is the number 3. One of them is the imaginary number 4i. And then the other one is the imaginary number negative 4i. Let's clean up, because we do have to FOIL these. Let's clean up any double signage that we have. So we got an x minus 3, an x minus 4i, and an x plus 4i. By the way, this function that you're coming up with has a leading coefficient. I should have left some room right here to move that equal sign and put a leading coefficient. We're going to have to find that ourselves. All right, but our task right now is to get this stuff all FOILed out. So here's the quickest way to get this done. Go multiply the conjugates first, because you got a shortcut for multiplying conjugates. I keep saying it. I don't know if it's ringing true with anyone. You know what the shortcut is for multiplying conjugates? Square minus square. Every single time. I don't care if there's imaginary numbers, just the fact that they're conjugate binomials. Anytime you have binomials, two terms, and they're conjugates, you can get them all FOILed out, all 5 steps in 2 steps. Square minus square. So you're best off doing that first, because it's going to really minimize what's in this problem. So all of this FOILed by the shortcut square minus square. This shortcut only applies to conjugates. Okay, so square minus square means either look here or look here, either one, and then square the front and square the back. I'm going to look at this one. So there's the front squared. Here's the back squared. You got to square the number as well as the I, and then put a minus in there. And then do you remember that ever since you've known about imaginary numbers that you've known the definition of I squared? That it's negative 1? So this is really negative 16 times negative 1, which is really positive 16. So all FOILed out and simplified, x minus 4i times x plus 4i is x squared plus 16. Drop down the x minus 3. And the a. I'm not worried about the a right now. I just want to try and finish foiling these out. Now what you should go to is traditional foiling, because you don't have a shortcut for this. So finish it off by x times x squared as well as x times 16, and then these little 2 upside down arrows, negative 3 times x squared as well as negative 3 times 16. So to finish this, or get closer to the finish line, I'm going to do traditional foiling. I used a shortcut at the beginning of the problem. Now I'm falling back to traditional foiling because there's no shortcut for this part. So x times x squared, x cubed. X times 16, 16x. Upside down arrows, negative 3 times x squared, negative 3x squared. Negative 3 times 16 negative 48. Okay, so there I am right there. When I give my final answer, I'll put these terms in order, but you know what I don't have yet? I don't have the A. And you guys are responsible, because sometimes it comes out to be a 1, negative 1, it could be 10, it could be 8, it could be anything. You are responsible for finding it. So let's go back to the problem, see what other information they gave me, because something has to be given for me to go on with me finding A. See that f of 2 equal to 20? Let's drag that into the problem. Look what they're telling you. Isn't there usually an x right next to the f? So they're giving you the x value here. They're saying that when you use an x value of 2, the y value is 20. That's actually going to allow me to find the a value that I need. So let's drag that into the problem. Okay, so let's see. I was told that f of 2 is equal to 20. That means when x is 2, y is 20. See the f of x that you see at the front? That is your y. So in place of this whole comment right here, f of x, which we know to be equal to y, you put the 20. A, I don't know what A is yet, and I'm not trying to copy that again. I'm trying to copy this. All right, now do you see in this big long expression that I was going to put here? Aren't we supposed to be using an x value of 2? So instead of me writing x's, I'll put a 2 in place of the x. And in that way, I'll have nothing left to find other than the a. Okay, so everywhere there's an x, I'm going to put a 2. So it's going to be 2 cubed plus 16 times 2 minus 3 times 2 squared minus 48. And I'm going to get one number here. See, this would be 4. Thank you. So that would be 8. 32. This would be 12. You know, 2 squared is 4. 4 times 3 is 12. And then a negative 48 at the back. Now put all those together. This plus this plus this plus this. It's negative 20. With a 20 over here. And now look, you got like a little baby equation to solve there. Negative 20 times a is that. So if you want to solve for a, just divide the negative 20 off. Divide by negative 20 on that side as well. And very soon you are into finding out that a is equal to negative 1. Now write the final answer. I'm going to write the final answer right here. Okay, so let's go back to f of x. Let's write it f of x style. My answer was going to be like this, the a value times all of this. Now I know that the a value is negative 1, so I'll toss that out front, but I'll go back to my x expressions. And I'm putting the terms in descending order. And if they want you to drag the negative in, that just means multiply everything by negative 1. And the only thing that's going to do is switch each of the signs. So it would be negative x cubed plus 3x squared and plus 48. Hope you have a good spring break. Stay safe, stay clean, sanitize.
My job and making us do extra cleaning. I work in the bakery department, so they're like, oh, I know that like you're supposed to leave in an hour. You're doing regular cleaning. Here's an extra 10 minutes of all the extra cleaning you gotta do.
Oh, jeez.
Every single shelf has to be sanitized every single night.
Oh, my
before
God.
I leave.
Where do you work?
So
God, I know. They must be going.
I make 3 kids cry. We give out free cookies. We're not right now because
Yeah.
we gotta be safe.
Yeah, I know.
Like, the parents are like, oh, like, thank you for like being concerned about everyone's safety and so forth, and then they're going down aisle 19 and the kids just start crying as soon as they realize you're not getting their free cookies. And I'm like, I'm sorry, like, I'm just following big orders.
Aw. They should switch over to prepackaged wrapped cookies and give them one of those.
Yeah, that's what I want to suggest to my boss, but I don't know. Like, we also have, like, self-serve donuts and rolls, and they're probably going to be changing that on us, too, and saying, like, either we have to serve them, or we're just not going to sell them at all.
Yeah.
And people love our self-serve rolls.
Nobody should be touching anything like that right now.
I usually don't buy them myself because people literally just stick their hand in and just start grabbing, like, squeezing
Instead of
the roll.
using the...
So, like, we have tongs.
people are so nasty. They're just so nasty.
We even started carrying, like, putting gloves over there for people. So they want to grab it, like, they have a glove to put on. So you don't even...
No, I'm not going out. I'm not hardly going out. If I get really hungry and run out of food at home, then I'll go out. Bye, you too. Stay safe.
Like, all my business partners are like, corona, stock market is crashing, all this is going on. I'm like, I know that, like, after a year of doing prerequisites, this is like business calc now. Last two math classes now.
Are you taking business calc right now?
No, not until fall. I did one last semester, my last semester for my associates. I took 2 math classes, 2 science classes, and art appreciation all at once to finish my degree.
Yeah.
And I died. I died that semester.
That's too much.
I went into my advisor.
Especially if you're working.